Hello everyone. Already I have posted three combined problems of UV IR and NMR spectroscopy. Let us discuss one more tricky problem. Molecular weight is 121. I know that the problems with the molecular formula or the problems in which percentage are given are little bit easy. That's why deliberately I am selecting all the problems with the molecular weight. So molecular weight 121, halogenated, that information is given. UV lambda maximum to 20 nanometer. There are 4 IR bands 3045, 2920, 1665 and 590. 3 NMR signals. Singlet delta 1.5 14 square. Double 8 delta 5.8 characteristic delta 4.5 square. And third signal double 8 5.65 again characteristic 4.6 square. So let us see the immediate information. First of all, we can say that compound is not aromatic. It is always advisable to first determine that whether the compound is aromatic or aliphatic. Second point, halogenated is already mentioned. Now total molecular weight is 121. So there is no question of the iodine because iodine's atomic weight is 127. We know that chlorine's atomic weight is a 35.5 and molecular weight is not integer. That's why half integer. That's why we can say that either two chlorine atoms should be present or one bromine may be present. From the three square values 14 and 4.5 and 4.6, we can say that the proton ratio must be ABC, that is 3 is to 1 is to 1. And second and third signal having very characteristic delta value 5.65 and 5.8. Now let us solve the example. I forgot to write the UV, but we can say that 220 nanometer, that is indicating absence of conjugation. Okay, 3045, that is alkene stretching. 2920 alkane stretching. 1665, there are two probabilities, either carbonyl or alkene cis trans. But here we can say that already 3045 alkene stretching is present, so most probably more likely alkene cis trans should be there, and 590 is of the carbon halogen bond and also halogenated, that is mentioned. Now let us analyze NMR data. First signal, second signal, singlet, doublet, doublet. Oh, this is not aligned properly. Okay, all the square ratio is when divided by the smallest number, then we are getting 3 is to 1 is to 1. So signal A 3H singlet, so most probably CH3 with no neighboring proton, its weight is a 15. Signal B 1 proton, that's why CH, its weight is a 13 and doublet, so there should be one neighboring proton. And 5.8 characteristic delta is of the that proton which is attached with the double bonded carbon, and also stretching of alkene is also given in the data, so both support each other. Similarly signal C, oh by mistake it is B written, again one proton and doublet, so CH with the one neighboring proton 13 its weight, again 5.65 is the delta of proton that is attached with the doubly bonded carbon. So we finalize three things, methyl, CH and CH, and these two CH must be attached with a doubly bonded carbon. So total 15, 13, 13, that we should subtract from the given molecular weight of 121. These three, their total is 41. So their difference is 80. So first thing, now 2 chlorine is not possible because sum of 2 chlorine atoms, their weight would be 71 and bromine's weight is 80. So apart from these three groups, CH3, CH and CH, bromine atom, one bromine atom must be present. And also we should remember that from the IR we can say that double bond is present. So two structures are possible, CH3, CH double bond CH and Br, which is very obvious structure. Another possibility is, but friend, uh, again and again I am telling you this, whenever you arrive at any structure as answer, always you should recheck and match it with the given data. In this structure you can see that the three protons first signal having one neighboring proton. So there should be doublet, and one of the signal with the one edge having the three neighboring protons. So there should be quartet. Here you can see that this is the signal having the 3H. So 3H singlet is given, not doublet. Moreover, none of the signal having quartet. So the structure which seem very obvious, very easy structure, is actually not our answer. Instead, this should be correct answer. We have to rearrange these groups. So here you can see that CH3 carbon bromine, double bond carbon hydrogen hydrogen. It means that this is vinyl protons, and already we know that vinyl protons are different in NMR, though they attach with the same carbon. So now you can see that CH3, this is its neighboring carbon. There is no proton over here. That's why singlet 3H. And these two protons, as they are non-equivalent and they both have one neighboring proton, that's why doublet and doublet is justified. So always remember that 4.5 to 6, this is the range of vinyl proton. So in our problem 5.65 and 5.8 is given. So the correct answer is this. So this is little bit tricky problem, as most of the students they immediately think about this. So that's why I have chosen this problem. I hope that you understand it.